So PyTorch has this capability of detecting the gradients of any kind of function, okay, along with the tensors. Okay, so tensors gradient can be calculated by Python, sorry, not Python, PyTorch at any point of time. Okay, so in this video we will deeply understand this gradient thing and how in PyTorch you can calculate the gradient, because this is one of the most important thing inside deep neural network and your neural network, because mostly in backpropagation gradient calculation and weighted adjustment happens. Okay, so let's say we'll see this figure how it comes. So first, let's say you are importing torch, and let's say you are creating one tensor with requires grad option equals to true. That means for this vector or tensor, basically we will be requiring gradient calculation. Okay, gradient calculation will be enabled. Now if you print x, you will see it's nothing but a tensor with a floating value of 1, and it mentions that we requires the gradient to be calculated. And let's say now I am creating one output vector of y, and y is equals to x minus 3 times x minus 6 times x minus 4. So this is a basic let's say equation or function of y that's dependent upon x. Okay, now if you write x dot backward, so this backward function enables the gradient calculation for all the backward elements or objects or tensors present or that corresponds to y, or from which y derives upward to the basically till the leaf node. Okay, so now if I hover on top of this backward function, you can see it mentions that it computes the gradient of the current tensor. That means it will calculate the gradient of y with respect to the graph leaf. So what is leaf here? Leaf is here x, because in this equation, okay, x, from x we are deriving y, right? So who is leaf? This one is leaf and this one is output. Okay, so it's clear, right? So once you enable this backward function for the current tensor, it will start a gradient check or gradient calculation with respect to the leaf one. And let's say in between the leaf and the current vector, there is intermediate vectors. So by default for those the gradient calculation will be omitted, and the calculation of gradient will happen using chain rule. Okay, so if you print x dot gradient, you will see the tensor value for 31. So how 31 is coming? So you have y equals to this. Okay, so now if I do a simple differentiation, right, dy by dx, I will receive, for when we are doing with respect to this, I'll receive this too, right? Control C, Control V, then a plus. I hope you guys have remembered how differentiation works, right? Then this one, okay, plus, now then this one, that means 3 and 4. So instead of 6, this 4 will be here. Okay, so this will be the basic dy dx. That means dy by dx, okay, at my x equals to 1, what will be the value? It will be, if I put 1 here, so it will be 18 plus, okay, 2 5 10 plus 3. Okay, right, 10 and 5, sorry, this one will be 15, not 18. Okay, so this one will be 15. Okay, this one will be 6 and this one will be 15. Okay, now this comes up to 31. Okay, the same value you will see a tensor of 31 value. So this is how a basic gradient calculation happens inside PyTorch. Now let's say in between your leaf node, which is x, and your output or the current vector or tensor basically, which is z, you have a intermediate tensor, that is y. So how you are going to calculate now dz upon dx, with respect to dx, how we will differentiate? You will use the chain rule that tensor basically PyTorch applies by default. So here dz by dx equivalent to dz by dy times dy by dx. Okay, this is a basic chain rule, and how inside your neural network this thing happens, basically your backpropagation and calculation. So first it will calculate the output z, let's say here, right, x y z. So let's say this is input, this is your hidden layer, this is your output. So first it will calculate the output z. Okay, z got calculated, then you have the level, that is let's say t, then you will get the error, right? Let's say MSE we are taking, so z minus t square, that will give you the error. Now weights for y, for this change x to y, let's say you have w1 as a parameter to be updated, and from y to z, let's say you have w2 is the parameter to be updated. Okay, so these weights can be considered as nodes as well. Okay, these are, let's say, some nodes that you needs to update, and that is the task of your neural network. Okay, now what will happen, your z is nothing but function of this y and function of this w2, and your y is function of x and w1. Okay, so what will the optimizer do? The optimizer will update these weights w1 and w2 based on the gradient. And how you are calculating the gradient, I have just shown, right, by using the chain rule basically. So for z, as z is function of y and w2, and w2 is a variable, so you do dz by dw2. Okay, and for y, again internally, y is a function of x and w1, so it will get calculated dz over dw1. Okay, and that's how you calculated dz by dy and dy by dx. Okay, so that's how your neural network calculates basically the weights. And now next one, it's, let's say you have a little bit more complex neural network, not complex, this, let's say these are the tensor representation, and now let's say you have each nodes. Okay, these are the elements inside tensors. So let's say for the input you have two inputs, x11 and x21. This second one is for layers, and these are the node values. Okay, and the second layer has also two inputs, or basically two hidden layers, hidden neurons, that has x12 and x22. Then your y is a combination of these two nodes, right, this node and this node, that means function of x12 and x22. And again your x22 is function of this two, and x12 is also function of this two. Okay, so let's say I'm creating one tensor or x11, that means this I'm assigning its a float value of 2, and I am enabling the gradient, and for 21 I'm assigning it a value of 3, again gradient on. Then I'm just defining random functions for x12 and x22, as it will be dependent upon this two and it will be dependent upon this two. Okay, so 5 x11 minus 3 times of x21 will be my x12, and x22 will be 2 times of x11 square minus 2 times of x21. Okay, and let's say I'm defining the output y equals to 4 times of x12 minus 3 times of x22. Okay, now let's say I want the intermediate values of gradient, how, like dy by dx2 or dy by x22 to be calculated and stored, and I wanted to see the equation or values for, let's say, debugging and check purpose. Then by default I have to keep those gradients to be retained in the memory, because for PyTorch by default these memories, right, it will only store the gradient of the leaf node, that means x11 and x21 will be visible by default. So to store the gradient of x22 and x12, you have to do a requires grad function to be called. And then the basic thing for calculation of gradient, you have to call the backward function. Once the backward function is being called, the gradient will be calculated automatically. Now you can see, as we have retained the x22's gradient, we can see the value of the tensor. Now if I do, okay, so let's just again call all of this, right, every time you have to call. So defining of these tensors, and then let's say mentioning that I want y and x22 to be retained, and then I'm calling the backward function. Okay, now if I call this x22 dot grad, that will give me the gradient of x22. But if I call, let's say, x12's grad, I will not see any attribute or the value, right, as it is mentioning that x12 here, if you see, it is not a leaf node, so by default PyTorch does not store this one. So to store or to debugging this value of gradient, you have to use this retain grad function before you call the backyard function. Okay, and for x12 and x11 it is not a big deal, you just call and you will see the values. Okay, let's say x12 dot grad, right, and I can easily see the value of that one also, x21, sorry, I'm extremely sorry, x21, 1 2 is for second node, right? Yeah, here you can see the tensor, or basically the gradient for x11 with respect to gradient for y with respect to x11 is -4, and with respect to x21 is -6. Okay, and if you don't want to write all of these codes, you can just use hooks. Basically you can see you have to register hook, and you can call the corresponding node, and you can print basically, or for debugging, the gradient for that intermediate node with respect to your output. Okay, and one thing I wanted to mention, commonly asked in any PyTorch interviews and all those. So by design, if you don't called y dot retain grad, and then you called y dot grad, okay, if you don't call the first function and you are calling this directly, by design you will get none as an output. Okay, and retain grad has to be called before the backward function, so that PyTorch knows that okay, intermediate gradient calculation needs to be stored, or else it will throw the memory. Just to save memory, it will throw those values. Okay, and again, if you detach any tensor, you will not get the output, okay, of the gradient. That's very understandable, right, if I use detach thing. Okay, and this is one example that I have used to show this common mistakes and pitfalls, so you can see that here as well. Okay, so that's it for this video. Just wanted to touch base upon the tensors, and also the gradient and back propagation, or backward calculation, how happens, and differentiation thing. So now I hope you have a very clear understanding of the differentiation and how to